Hello, dear friends. Welcome to the second session of this mini course. In this session, we are going to introduce the necessary software that we will need and then do our very first test with the fascinating world of microcontrollers to see, in detail, how things actually work. So basically, we need two pieces of software. Since in microcontrollers, we have the topic of simulation on one hand and programming on the other, and each of these needs to be done with separate software, we need two different pieces of software. The first topic we're going to cover is simulation. For simulation, there may be several software options available, or even some websites that allow you to simulate circuits. But one of the best options, which covers most microcontrollers to the extent we need, has a lot of components, really makes your work easier, and you might already be familiar with it, is the Proteus software. With this software, you can simulate everything from very simple circuits to even more complex and unusual circuits, microcontrollers, LCDs, displays, and so on. It's a very comprehensive and robust software, and if you delve deeper into its extensive capabilities, you'll clearly see that it really can effectively meet many of your diverse needs. Always make sure to download the absolute latest version available. One thing to note is that if you download a file related to this software from somewhere and it was saved with a newer version, you won't be able to run it with an older version. For example, if you already have versions 8 and 9 installed on your system, you won't be able to open files from versions 8 and 17 in them, and you'll get an error. So always try to keep this software updated, and whenever a new version is released, uninstall the previous one and install the new version again. In addition to this software, we also need software for programming. Well, each family of microcontrollers has a set of software that supports them, and it's not like we're only dealing with one or two programs. There are actually many more than that, but one of them really makes things much easier. Since our primary goal in this comprehensive course is to explain absolutely everything in very simple and understandable terms, one of the most effective programs that truly makes things significantly easier and more manageable is indeed CodeVision. Because it allows you to do a series of settings graphically, and then it converts them into code for us, handling many of the initial configurations of our microcontroller. And another significant point to consider is that different software applications might utilize various programming languages, but the fundamental way in which they operate and function is, in essence, pretty much the same across all of them, regardless of the specific language used. For example, right now with CodeVision, we program using the C language. Previously, there was a software called Bascom that used the BASIC language, but it's now obsolete. Although until just recently it was still used in many universities and such, but basically it shouldn't be used anymore. That was also a very easy and good software, but in the end it's something that's now outdated. Or for example, many other software might use C++, and again, by learning the C language, you can easily program in C++ as well. And a very important point is that in this mini course, where our main focus is on the microcontroller itself, and also in the main course that we promised you, we'll try to cover as much of the C language as possible, and maybe even hold a separate course just for the C language. But the important point is that you have to practice yourself, because learning a programming language doesn't work in such a way that with 2 sessions, 10 sessions, 20 sessions, a university semester, or an educational course, you can master a programming language. It really requires working on it and practicing. Now, as much as it is truly possible, we will provide you with what you thoroughly need to commence your crucial journey. But of course, you also indeed need to regularly practice it. So let's go and see what the software itself looks like. I'll start with the Proteus software. When you open this software, well, on the initial screen, like most software, there's nothing particularly special, but if you look at the top menu, we have a schematic option. There's a PCB option. There's also a 3D option, which shows us the PCB in 3D, along with many other features that this software offers us. But for circuit simulation, what we need is the schematic section. If we enter the schematic section, it provides us with an environment where we can start placing our components, make our connections, and finally run our project. So to add components, right here in the selection board section, you click on this key and add the components you want. It has both a search feature and several categories. For example, here we have analog ICs, capacitors, or diodes. If we scroll down, for instance, we have inductors. We also have resistors. We can also add things like speakers, for example, switches, relays, and other items that fall into this category. On the other hand, we have transistors, and overall it has a very comprehensive categorization. Each of these also has its own subcategories in manufacturers, so overall it's a very thorough classification. This helps us get familiar with the components in the first place, but often we already know what we want and just search for it. For example, right now, I want to build a very simple circuit where with a switch and an LED, we can turn the LED on and off. So if I search for an LED here and start looking through the list, we'll see that it offers us a range of LEDs. Now the first item is just a display, but the rest show different types of LEDs, and here it also explains what color each one is and what it looks like. For example, here I'll pick a green LED. I confirm it and it gets added to my list. Now I come here and I already know that, for example, the button is called button, so I search for this button, it brings it up for me, and I confirm it here. The button also gets added to my list. Now for example, I can also very easily add a battery component, and as you can clearly see, it promptly brings up various different types of batteries for me to choose from as well. I don't know, multi-cell battery or something like that. And well, for example, we can also use a battery, but I don't want to add a battery right now. I'll explain the reason to you. So we come here, place an LED, and put a button up here as well. Let me zoom in a bit and we'll make this connection here. Now, well, our LED needs a positive and a negative connection. Here we don't have to worry about burning out the component or anything like that. For now, we won't add a resistor, but in the real world, for example, you would add a resistor here as well. We come here, and in this side menu section, we have terminal mode, which gives us a power and a ground. Our power is 5 volts, and the ground is, well, the circuit's ground. We add this ground here, and we place this power here as well. Again, in the real world, we know that, for example, 5 volts would burn out an LED, but here it's a simulation, and if we run the project by pressing this button, we'll see that the LED lights up. We've just built one of the simplest circuits possible in Proteus. You can also explore the features of the software a bit more. For example, in this side menu under the generator mode section, we have things like sine waves or DC voltage, where we can set the voltage ourselves and have it generate any voltage we want, or we can generate pulses. Or for example, here in the instruments section, we have the oscilloscope. If you're familiar with it, it's used for frequency analysis and such. Or for instance, we have some counters and timers. We also have a voltmeter, which you can use in your circuit designs, and overall, it's really a comprehensive software. There are also some shape drawing tools and such so that your software and simulation can look neater. If, for example, you need to present it somewhere, perhaps for a significant presentation or an important demonstration, then it's really and truly up to you to thoroughly explore the software as much as you possibly can and become intimately familiar with all of its various features and functionalities. Right now, we're just going to introduce the software and then we'll move on to using microcontrollers. For microcontrollers, we can also start searching in this same list and find the ones we need. For example, if I search for the Atmega 32, which we're going to work with, you'll see that it comes up and we can use it. Or for example, if I just search for Atmega, you'll see that it supports a list of Atmega chips and we can use them. Now, for instance, for a simple circuit where I want to write the program in CodeVision myself, I add an Atmega 32 to the list. How does it work? I'm deleting this. I'll add my Atmega 32. Well, the essential point is that in microcontrollers, we inherently possess a comprehensive series of various input and output ports. That means it comes and categorizes the bases. Now, as you can see here, it says that these 8 pins are port A, these are port B, these are port C, and these are port D. Now, we also have some extra pins that we won't deal with for now. In this categorization, each pin is identified by its port and its number. For example, this pin of mine becomes pin 3 of port A, or this pin becomes pin 0 of port C. And in our programming, we specify them in this way. For instance, we say, consider pin 0 of port A as an output or as an input, and we do whatever we want with it. Suppose I want to connect an LED to pin 0 of port A for now. I connect the ground of my LED, and we want to write and run a blinking code together on it. So this becomes one of the most basic circuits. As you can see, we're working with the microcontroller in a very straightforward and simple way, and if you wanted to work with any other IC, you would have had a lot of other connections to make. Now in the real world, this microcontroller also has 2 power supply pins, but here in the simulator we don't have the power supplies. Still, you can see that it has everything built in very simply, and all we need to do is connect whatever we want to it and start the project. And for example, an IC like the 555, which you're probably familiar with, and which we also have here in Proteus, well, it had a lot of other pins. For instance, we would use resistors and capacitors with it to get the function we wanted. But with a microcontroller, it's not like that. Now, I'll move on to CodeVision. CodeVision is the software where we're going to write our code. It makes the code executable on the microcontroller so that in the end we can run it on the microcontroller. When we enter the software, it has different sections. For example, here we can add a series of ready-made codes. Some codes that we know we'll want to use everywhere, or some of the C language commands are also provided here for us. We have the clipboard section where things we copy appear here so we can use them. On this side, we have our file list and some other features that we don't need to deal with for now. To create a project, we go to File, select New, and then click on New Project. It asks us whether we want to use the code wizard or not. The point here is that this is where CodeVision really shines. It's actually its main advantage and a very useful feature. We have a set of hardware configurations in the microcontroller, and these hardware settings are done through a series of registers. We might go into more detail about this later. And these hardware settings, well, memorizing the registers and how to configure them is difficult. Either you always need to have a reference book handy to look things up, or you have to work with them so much that you eventually memorize them. And to save us from these difficulties, CodeVision provides us with a graphical environment where we can make any settings we want, and then CodeVision itself will handle configuring the registers for us. So basically, in all projects, even in many more advanced projects, we use CodeWizard. It handles the settings for us and really makes our work easier. So it asks if we want to use CodeWizard to write the code. We say yes. It asks which microcontroller series it is, which is Atmega, and we confirm that. Let's wait a bit for it to enter the CodeWizard environment. Well, in the CodeWizard environment, the first setting we have is selecting the microcontroller. It asks which microcontroller do you want to use. For example, here we see that it has a series of Atmega microcontrollers. It has the Atmegas, and the microcontroller we want to use here is the Atmega 32. Just like a computer CPU, as I mentioned, microcontrollers also have different processing speeds. Here the processing speed of the microcontroller is also adjustable, but for now we don't need to touch it, and for all the projects 1 MHz is perfectly fine. In Proteus, if we double click on the microcontroller, we can see that its clock is adjustable, but by default, whether it's the one we buy from the market or the one we simulate, it's set to 1 MHz and we don't need to do anything with it. Let's go back to CodeWizard. We can see that it gives us a lot of different settings, and these are all the internal units of the microcontroller. Just like I showed you in that microcontroller architecture diagram in the first video, here we can, for example, configure the serial settings and so on. We can configure the LCD settings, and it gives us a lot of options. But for now, at this first stage, what we want is the ports section. The ports section shows you the same categories I mentioned, ports A, B, C, and D, and each one has 8 pins from bit 0 to 7. And the point is that in general, the microcontroller pins can be configured in 2 modes, either as input or as output. For example, when we want to connect a button to a pin, we're providing input to the microcontroller, so that pin should be set to input mode. As you can see, this is the current mode. But when we want to set a pin to output mode, for example, to connect an LED to it, the microcontroller is sending output to the LED, so that pin should be set to output mode. So we set that pin to output mode. Now we want to connect an LED to pin 0 of our port A, so we set that pin to output mode. On the other hand, those pins can be either 0 or 1 when they are in output mode. In input mode, we also have the topic of pull-up, but we won't get into that for now. But in output mode, we have 0 and 1. This means that if it's 0, the voltage on that pin is 0 volts. If it's 1, the voltage is the microcontroller's supply voltage, which is 5 volts, and by toggling this pin between 0 and 1, we can, for example, make an LED blink. So, the default value we set on the pin should also be 0, so that, for example, our LED is off and we don't have any other settings. We go to this Generate Program section and create our program, that is our code. One thing to note is that CodeVision saves a lot of files. Be sure to give them the same name so they don't get mixed up, and also have a dedicated folder for CodeVision for each of your projects. For example, right now I'm creating a folder here called CodeVision for the project, and I'll name my project PRG. And you'll see that it asks us to save several times, so use the same name for all of them so the files don't get mixed up. Again, PRG. And we wait for it to generate the code for us. Okay, our code has been created, and as you can see, it provides us with a programming environment in the C language. After we've written our program, at the end we use this button. Build all turns the entire program into a file that can be run on the microcontroller. From here on, I'll just put a very simple code so that we only have a blinking LED. In our next sessions, we'll also try to get into the C language as much as possible. But as I told you, it's necessary to work on the C language separately, because that's what really improves your microcontroller skills. Apart from the electronics aspect, being able to program it well is really important, and that's a crucial point. Well, when it comes to the C language, there might be people watching this video who are already quite familiar with it, or some who aren't familiar at all. I can't cover both groups in this video. Right now our video has already gone over 20 minutes and you might be getting tired as well. So I'm not going to get into the C language itself right now. I just want to see how much code it takes to make a blinking LED. In the next 2 or 3 sessions, we'll thoroughly go over the C language in our examples. Alright, so here in the main code section, what do I need to put? First of all, a library needs to be included here. Now, if anyone is familiar with the C language, we include libraries so that we can use the functions inside them. And now here we say set port A.0 to 1, meaning set pin 0 of port A to 1, make it 5 volts. After that, wait for 500 milliseconds or half a second, and then we repeat the same process and set that pin to 0. This way we have a blinking LED that is on for half a second and off for half a second. Just these 4 lines, these 4 words, and we hit build all. There's nothing else we need to do. Now let's move on to Proteus. We double click on the microcontroller. We select our CodeVision file from the folder. Click OK, run the project, and you'll see that a blinking LED was created this easily. Whereas, for example, in circuit design, for this part, we would have to use a capacitor, resistor, transistor, and so on, just to have a blinking LED. Or for instance, we might have to use a 555 IC. There are different methods, but as you can see with a microcontroller, without any extra work, without any circuitry, without any particular difficulty, we're now creating a blinking LED with just 4 lines of code, and each line is barely more than a single word. And that's precisely the significant appeal of working with microcontrollers. You can very easily and efficiently implement your innovative ideas, and you no longer really need that extensive circuit design knowledge. This doesn't mean that we don't need circuit design knowledge, because in mass production or in industrial applications, there are many cases where, for example, using a microcontroller might suddenly not be cost effective. Now, it really depends on the project and the specific task that needs to be done. But for some simple tasks, well, maybe in mass production, someone doesn't want to spend tens of thousands of tomans, or maybe 100 or 200,000 tomans on a microcontroller, and instead says, build this circuit for me using transistors. For example, the total cost might not even reach 2,000 tomans, and these are the points to consider. But this is the difference that exists here, and well, this is also the appeal of microcontrollers. That wraps up the second session. I hope you enjoyed it, and in the next 3 sessions, most likely 3, we'll go through more examples and do some implementations together. Thank you for staying with us, and goodbye.